All right, we are done with chapter 14 now, the expenditure multiplier. And we are now going to begin the next chapter, which in this case is not 15, but 16, as your syllabus will tell you. Okay, so we're not following a sequence now, we're jumping around a little. Okay? But I believe that the sequence that we have in the syllabus is a more natural sequence than the progression of chapters in the book. So chapter 16 deals with what's called fiscal policy, a term that we have already introduced in class. Again, quick background. By now you should be very familiar with this idea, but I'm going to quickly draw the diagram for an economy in recession. Real GDP, price level, aggregate demand, aggregate supply. This here is our equilibrium level of real GDP, and potential GDP, or full employment real GDP, is to the right of Y star. So this is YF, full employment real GDP, and that gap there between Y star and YF is called the recessionary gap, and this is a gap that needs to be narrowed. How is fiscal policy going to accomplish this? Well, fiscal policy will aim to shift the aggregate demand rightwards. Do you follow me? Because once the aggregate demand curve is made to shift rightwards, and if it were made to shift rightwards all the way to here, the red line that I'm now drawing, right? If the AD curve was shifted all the way to this AD prime, then of course we would have equilibrium where? We would have equilibrium here, and that would give us an equilibrium level of real GDP that is going to equal potential GDP. So the recessionary gap will have been eliminated. Is that correct? So this is the story, right? And how is the government going to use fiscal policy to bring this about? Now remember, fiscal policy is policy in regard to two things: government spending and taxes. And these are both in the hands of the government. When I say government, I mean the executive branch and the legislature. So we're talking about the president and Congress. They're in charge of fiscal policy. Right? We've learned in chapter 14, when we discussed these various multipliers, that the way to increase AD was by raising government spending or cutting taxes. Is that correct? And according to our theory in chapter 14, these will have multiplied effects on AD. Is that correct? Does anyone recall the value of the government spending multiplier? The government spending multiplier, according to our theory in chapter 14, is equal to 1 divided by 1 minus the MPC, precisely. And if you work with an MPC of, say, 0.9, this will give you a value of 10. Is that right? If the MPC, if this were equal to 0.9, then the whole thing would be equal to 10, which is to say that a $1 increase in government spending causes a $10 increase in aggregate demand. Right? What is our tax multiplier equal to? Negative MPC divided by 1 minus MPC. So once again, if we work with an MPC of 0.9, this will give us a value of negative 9. which is to say that if the government raises taxes by $1, AD should reduce by $9. Conversely, if the government were to lower taxes by $1, aggregate demand would rise by $9. So this is what our theory in chapter 14 told us. Is that correct? So all of this came out of chapter 14. Now in this chapter, chapter 16, we are again going to get into some details of this, and importantly, we are going to critique chapter 14. Okay? And I'll tell you what the problem is. Even though theory tells us that the government spending multiplier ought to be a large number like 10, economists have estimated the government spending multiplier to be actually much smaller than 10. See? And here we have again a debate. Macroeconomics, by the way, is one area of economics where there is considerable debate between different schools. There are different schools of thought in macroeconomics. Now, this is not common in the other subfields of economics, but in macroeconomics, you have still a considerable debate between various factions of economists. And, well, I'm going to give you a few names here of famous economists. And there's one called Christina Romer. Christina Romer is a professor of economics at Stanford. And she was also chair of the President's Council of Economic Advisors. I'm not sure if she's still the chair, but she used to be, certainly. And according to Christina Romer's estimates, the government spending multiplier was nowhere near 10. It was more like 1.6. More than 1, but certainly not anything like 10. Now, what does that 1.6 mean? How would you interpret that 1.6? Could you give me a sentence that uses that 1.6 to explain its meaning to me? So according to Christina Romer, what would happen if the government raised its spending by $1? Aggregate demand would increase by $1.60. 60 cents. 1.60. Is that correct? So according to Christina Romer, if the government raises its spending by $1, aggregate demand in the economy would go up by $1.60. More than $1, certainly, but certainly not anything near $10. So we still have a multiplied effect, but it's a very modest multiplied effect. That's according to Christina Romer. Now, we have another economist here called Robert Barro. Robert Barro is a professor of economics at Harvard. As far as I know, he's never held any kind of public office. But according to him, the government spending multiplier is actually a number less than 1. He believes it to be 0.8, which would basically not even make it a multiplier. Correct? So according to this 0.8, what would be true if what would happen to AD if the government raised its spending by $1? AD would go up by not even that dollar. It would go up by less than $1.80. Now you would think that if government spending goes up by $1, AD should go up by at least that because government spending is a part of AD. Am I correct? But it turns out, according to Barro, that in fact, the increase in AD is less than the increase in government spending. So what's going on here? Both these numbers, 1.6 and 0.8, are considerably smaller than what our theory in chapter 14 predicted with an MPC of 0.9. We ought to have a government spending multiplier of 10. But both numbers these two economists have come up with are much smaller than that 10. So what's the reason for this? Is the next thing we're going to discuss. And the phenomena that is responsible for this big decrease in the true value of the government spending multiplier is called crowding out. So this is what reduces the effectiveness of fiscal policy. It results in a big reduction in the value of the government spending multiplier. So what is crowding out? Crowding out is the phenomena by which an increase in government spending causes the sum of consumption, investment, and net exports, the other three, in other words. It causes this sum to reduce. In other words, an increase in government spending pushes out the other three spendings. So this is what crowding out is about. An increase in government spending causes the other three spendings to reduce. So how would you think about this in terms of our diagram for the economy? This diagram. So if crowding out were to happen and the government raised its spending, you would have a rightward shift of the AD curve from the black AD curve to the red one. But then because the other three spendings would be reduced, you would have a shift back leftwards, like this. And so in the end, your AD curve settles at not the red line, but perhaps this green line. Am I making sense here? So you can think of this in basically two stages. The government increases its spending. According to the government spending multiplier, this will result in a rightward shift like this. A rightward shift like this from the black to the red. But then there'd be a shift back leftwards from the red to the green. Am I making sense? So in the end, the effect, the net effect of this is going to be a movement from black to green. Am I making sense? So this is what crowding out does. It clearly reduces the impact of the increase in government spending on aggregate demand. Instead of going all the way from the black AD curve all the way rightwards to the red one, which is what you need to eliminate this recessionary gap shown here. Now, the same increase in government spending falls short of its objective, correct? The AD curve shifts now from the black to the green, not black to red. Do you follow me? Now, what is crowding out? How does it happen? Why does an increase in government spending cause the other three spendings, or the sum of them, to fall? And here are some explanations. The first one is a very simple explanation. And this is that if the government increases its provision of goods and services to households, households shall reduce their consumption spending. Okay, if the government increases its provision of goods and services to households, households shall reduce their consumption spending. Let me give you an example of this. Let's say that the government, as part of its expansionary fiscal policy meaning policy designed to shift the AD curve rightwards, expand equilibrium real GDP. So as part of its expansionary fiscal policy, the government decides to build a new public library in your neighborhood. Right? So within walking distance of your home, you now have a public library. What will this do to your own magazine subscriptions. So this is a very simple example of crowding out. You have the government increasing its provision of magazines and books to you via that public library, and you reduce your personal purchase of new magazines and books. This is crowding out, isn't it? So according to this, government spending is going up, and this is causing consumption spending to go down. So this is a very simple story. Another example like this would be, let's say that the increase in government spending took the form of the government improving public transport in town, more buses, okay? And let's say that there is a nice bus stop, a spanking new bus stop right outside your home. That will bring you straight to school, right? What would this do to your purchase of a new car or gasoline? Reduce it, am I correct? Because you're more likely, you'd probably take the bus now and then, often, right? So this is another example of crowding out. This is a simple crowd story, right? But now there are some more complicated stories that I will talk about. And before I talk about these complicated stories, I'd like to remind you of the connection between the rate of interest, R, and consumption spending, investment spending, and also net exports. What is the connection between the rate of interest and, let's say, consumption spending? If the interest rate rose, what would happen to consumption spending? It would decrease. Why would it decrease? And how would that impact your consumption spending? It costs more to get what again? Yes, on credit. That's what's important. Anything that you buy on credit will now be more expensive to you with a higher rate of interest. And we households, we certainly buy lots of items on credit, particularly the expensive items, right? So a rise in the interest rate is likely to cause consumption spending to fall. What about the effect of the interest rate on investment spending? Investment spending, remember, is mainly the purchase of new machines by businesses. Now, don't businesses also often borrow money to buy machines? Right? So if the interest rate were raised, a simple story would be that, well, finding credit more expensive, businesses will be less likely to take out business loans with which to buy new machines, build new factories. Right? So a rise in the interest rate also then results in a fall in investment spending. Now, what about net exports? What's the story there? Is there a link between the interest rate and net exports? Okay, let me ask you another question. Is there a link, do you think, between the exchange rate, the currency exchange rate, and net exports? Is there a connection? If you define the exchange rate as the number of pesos per dollar, and if this exchange rate were to, let's say, rise, more pesos to a dollar, which is basically a stronger dollar, what will this do to US net exports? Any thoughts? Now, our exports are what foreigners buy from us. So you might think very simply of our exports as the shopping that Mexicans do over here in Brownsville. Correct? So if there are more pesos to the dollar, would more Mexicans come and shop here in Brownsville or less? Yes, that's what I'm getting at. Now, why less? For them. Because anything that has a US dollar price tag will now convert to more pesos. So our goods will seem more expensive to them. And so exports shall fall. Is that correct? Now, what about imports? Imports are what we buy from foreign countries. So you might very simply think of this as the shopping that we do in Matamoros. Am I correct? What would happen to that if, now again, this is a very simple example. Our exports are not just Mexican shopping in Brazil, am I correct? I'm giving a very local, simple example. We export stuff to Mongolia, China, India, whatever, and they don't come here to shop. We ship it to them. Am I correct? However, let's look at the effect of this exchange rate on imports. With a stronger dollar, will foreign goods be more expensive for us or cheaper for us? Wouldn't we then buy more foreign goods? Right? So therefore, we have X falling and M rising. And what does this do to the whole thing? X falling by itself would cause X minus M to fall. M rising, well, that by itself too would cause X minus M to fall because you're now subtracting a bigger M from a given X. Is that correct? So both of these would cause X minus M to fall. Is that correct? So a stronger dollar would cause a fall in net exports. Now, is there a connection between the rate of interest and the exchange rate? Is there a connection between the rate of interest and the exchange rate? And again, here we say, yes, there is. I'll tell you how this works. If the US interest rate rises, the following is likely to happen. Remember, in the world, there is a whole pile of money belonging to wealthy people that simply goes around the world looking for a high rate of return. Do you follow me? So you have all kinds of money managers, they're called, companies that manage other people's wealth. And all these money managers, all they do all day is ship this money around from country to country, electronically, of course, so the money can earn the highest rate of return possible. Right? Now, if the rate of interest in the States were to rise, this money, or a large chunk of it, would try to come to the States to take advantage of this higher rate of interest. Because a higher rate of interest in the States would mean that our banks, our financial institutions, are paying out a higher rate of interest. And this money would like then to park itself in our banks. Right? So now let's consider some rich Mexicans out there. So this is money in pesos. And they'd like to ship this money into US banks to take advantage of the higher rates of interest that we are now offering. But pesos can't simply be put into a US bank. They would have to be, what? Converted into dollars first. So these guys would have to buy dollars. Am I correct? They would have to buy dollars in order to put their money into US banks in order to avail of these higher rates of interest. Now, I'd like you to think very simply of a market for dollars. So this is a foreign exchange market. So this is a market for dollars. So here we have the quantity of dollars, the demand for dollars, the supply of dollars, and here we have the peso price of a dollar on the vertical axis. So this is a market for dollars. Now, with all those Mexicans trying to convert their money to dollars so as to put their money into US banks, what would happen in this diagram? Well, the demand for dollars would increase. There is an increase in the demand for dollars by these Mexicans trying to buy dollars. Is that correct? So what does that do to the peso price of a dollar? The peso price of a dollar used to be this. So let me call this E1. That used to be the exchange rate between the peso and the dollar. But now you will have a higher exchange rate. So what's happened here? The dollar has become stronger. Am I understood here? So basically the connection here is that when the interest rate rises, the exchange rate rises. The dollar becomes stronger. Stronger dollar. And a stronger dollar crowds out net exports. So you have then a rise in interest rates causing X minus M to also fall. Correct? So this is the connection between the rate of interest and consumption spending, investment spending, and net exports. All three go down when interest rates in the US rise. Correct? All right. Now coming back to crowding out. Let me go to a new slide here. So let's say that, so this is our second kind of crowding out. So the story here is as follows. Government spending rises without a rise in taxes. So this is not a government that's trying to keep its budget balanced, clearly. Do you remember the balanced budget multiplier that we discussed in class last time? In that story, the government raised its spending by a certain amount and raised taxes by the same amount in order to fund the increase in spend. Correct? But here we have a different story. Here we have the government raising its spending without raising taxes. So this is like you increasing your spending without an increase in your income. How would you do this? How would you manage this? How would you personally increase your consumption spending without an increase in your income? Borrowing, precisely. You would borrow. And so, in this case, the government would have to borrow. So this is going to lead to government borrowing. Right? Now, what is government borrowing likely to do to the interest rate in the economy? And for this, we need a market for loans. And I'm going to draw a little diagram here again. So this now is a market for loans. Now you see how important that first part of this course was when we discussed demand and supply analysis, because that can be applied to so many different situations. Okay? So now we're talking about a market for loans. So in this diagram, here we have the quantity of loans. This is the demand for loans. This is the supply of loans. And what would be the price of loans? The price of loans? Well, the price of loans is the interest rate, of course. You can think of that as the price of loans. So we have the government increasing its borrowing. What is going to happen in this diagram as a result of this government borrowing? There will be an increase in the demand for loans. You see that? Now, with an increase in the demand for loans, what happens to the interest rate? Well, the interest rate used to be R1. But now, with government borrowing coming into the picture, you have a rise in the interest rate from R1 to R2. You follow? So what's our story going to be then? Government borrowing. Now what does government borrowing do again? Government borrowing causes the interest rate to rise. And we now know what a higher interest rate does to C, I, and X minus M. Right? A rise in R causes C to fall. It also causes I to fall. And it also causes X minus M to fall. So isn't that crowding out now? You have an increase in government spending, and this causes a decrease in consumption spending, a decrease in investment spending, and also a decrease in net exports. So this is our more complicated crowding out story. It works through the interest rate. Now there is also a third story. And the third story is like this. The third story, by the way, is due to, again, Barrow, Robert Barrow. So what does Barrow have to say about crowding out? He says the following. Once again, you have the government raising its spending without raising taxes. And so the government must borrow. So far, so good, right? Now, when we observe, we households, when we observe that the government is borrowing more, it of course occurs to us that the government will have to repay more in the future. If the government's borrowing more today, of course, it must mean that the government must repay more money in the future. Where will the government get the money from to repay its debt? Where will the government get the money from to repay its debt? From us, in the form of taxes. So therefore, when the government is borrowing more today, we households, we start to expect higher taxes in the future. Does that sound credible? So we start to expect higher taxes in the future. And how does that impact our consumption spending today, do you think? Hold on a second. To make things clearer to you, let's say that in the month of February or so, you get a letter from the county explaining to you that the value of your home for tax purposes has greatly increased. You know what I'm talking about? So you get a letter in the mail saying that the house you live in, which used to be valued at, let's say, $150,000, is now valued at $200,000. Hence, come October or so, you will have to pay more property taxes than last year. Is that making sense to you? Now, because you expect these higher taxes, what happens to your spending today? Don't you already start to save more money to pay those higher taxes? Right? And that's exactly what's going to happen here in this story. So in this story, households expect higher taxes in the future, so this causes households begin to save more to pay these higher taxes. And what does save more mean? Save more, of course, means that consumption spending reduces. That's how you save more, by reducing your consumption spending. So this is, again, another crowding out. You have an increase in government spending, and this is causing a decrease in consumption spending. So that is another kind of crowding out. So the point here is we now have an understanding of crowding out, correct? I'm going to introduce now another term to you, well, two terms. One of them is called complete crowding out, and the other one is called incomplete crowding out. Now, what is complete crowding out? Complete crowding out takes place when a government spending increase of $1 causes C plus I plus net exports to go down by exactly $1. So the government spends $1 more, and this causes the other three shoppers to together spend $1 less. Now, in this case, will government spending have any impact on AD? Would the increase in government spending have any effect on AD? Would it? So in terms of this diagram here, you have the AD curve shifting from the black to the red because of the $1 increase in government spending. But now the other three spendings go down together by $1. So wouldn't you just simply go back from red back all the way to black? Yes, right? So you would now have a shift all the way back to square one. Am I correct? So in this case, the increase in government spending would have no impact on AD. So this is complete crowding out, right? So with complete crowding out, you have fiscal policy is completely ineffective. Fiscal policy is completely ineffective. Now, what about incomplete crowding out? Incomplete crowding out is when government spending rises by $1, and this causes C plus I plus X minus M to go down by less than $1. Now, will fiscal policy have some effect on AD? Yes, in this case it will, right? This is kind of like what we originally spoke about of. So this would be like going from the black AD curve to the red one, and then back leftwards, but not all the way back to square one, but back to the green AD curve, right? So with incomplete crowding out, fiscal policy is somewhat effective, correct? It's not completely ineffective. However, it is less effective than it would have been in the absence of crowding out. So crowding out certainly reduces the effectiveness of fiscal policy, right? Okay, let me give you a little math problem here that will help you work out this crowding out story, okay? And the problem is as follows. The marginal propensity to consume is 0.8. Government spending rises by 100 million. This increase in government spending causes $50 million of investment spending to be crowded out. Calculate the net increase in aggregate demand. How would you tackle a problem like this? So we have two things happening at the same time. We have a delta G of plus 100 million. Is that correct? Government spending is going up by $100 million. And at the same time, we have investment spending going down by, correct? Couldn't we find the effect of each separately on AD? And then add these two up to get a combined effect? Yes? Let's proceed to do that. So how would we calculate the effect of each on AD and then add up the two changes in AD to get the combined effect? Well, what's the formula we need to employ? The two formulas that we need to employ are delta AD is equal to delta G times the government spending multiplier. And delta AD is equal to change in investment spending times the investment spending multiplier. Right? So what is this going to be equal to? Plus 100 million times, what's the value of the government spending multiplier? 1 divided by 1 minus 0.8. So this would be plus 500 million, because 1 divided by 0.2 is 5. What is this equal to? Minus 50 million times, again, what's the value of the investment spending multiplier? Same as the government spending multiplier, correct? Minus 250 million. So what's the net change in AD? Plus 500 million minus 250 million is equal to 250 million. Yes? So we have the rise in AD of 250 million in the story. We will stop here today.